In this video, you will learn how to solve different problems in stoichiometry. What mass of silver could be formed if a large zinc wire is placed in a beaker containing 145 milliliters of 0.095 mol per liter silver nitrate and allowed to react overnight? Assume the reaction has a 97% yield. So before solving this problem, we need to write a balanced chemical reaction. So we have here silver nitrate and zinc reacted with silver nitrate, and this produces zinc nitrate and silver. So we balance this reaction here. It would be 2 nitrate, so 2 silver, and then don't need, right, I think that's balance. Our nitrogen is 2 moles, oxygen 6, and silver 2, zinc 1. All right, we can now solve the problem. So we're given here 145 milliliters of 0.095 molar silver nitrate, or mol per liter silver nitrate, and also the percent yield, which is equal to 97%. We are asked for the actual yield of, or the mass of silver that could be formed in the reaction. So we need to solve for the theoretical yield first, since we are given the expected values and the percent yield. So we solve for the theoretical yield first. Okay, let's convert 145.0 milliliters to liter. 145.0 ml. This is just equivalent to 0.145 liter. You just have to divide that by 1000 milliliters. So we start from there. So 0.145 liter silver nitrate. We multiply this by the molarity to get the number of moles of silver nitrate per liter AgNO3, and then we multiply this by the mole ratio of silver and silver nitrate, since we need to solve for the mass of silver. So this is 2 moles of silver is 2 moles of silver nitrate, and then we multiply that by the molar mass of silver, which is 107.9 grams per mole. Okay. So liter here cancels out. Moles of silver nitrate cancels out, as well as moles of silver. Then we're left with grams silver. So this is the expected value or theoretical yield. So let's calculate that, and this would give us a value that is approximately equal to 1.49 grams of silver. And then we're given the theoretical yield, which is 97%. Okay, we use that to find the actual yield. So percent yield equals the actual over the theoretical times 100%. This is 97. We plug in all the given values and the value or the mass of silver that we got. This is 97% equals, okay, we don't know the actual, divided by 1.49 grams times 100%. So the actual yield is just equal to 97% times 1.49 grams divided by 100%. And this would give us a value of 1.44 grams of silver. So this is the mass of silver that could be formed if a large zinc wire is placed in a beaker with silver nitrate. Alright, let's solve another problem. What volume of 0.105 molar of silver nitrate solution would be required to react completely with an excess of magnesium chloride solution to produce 8.95 grams of precipitate? Assume the precipitate, precipitate is only 75% pure, as it is still damp following filtration. So begin with a balanced equation. So we need to write a balanced equation here. So silver nitrate react with excess magnesium chloride. This would produce magnesium nitrate and silver chloride. And we balance this reaction, so we have 2 nitrates, 2 silver, so 2 silver there. All right, so our equation now is balanced. So we need to solve for the volume of silver nitrate in liters. So we start with the given value here, 8.95 grams of precipitate, and it says it's only 75% pure, so we need to multiply that by 75%. So 8.95 grams times 75% divided by 100. So this is just equal to 6.7125 grams of silver chloride. Okay, so we use that mass to solve for the volume of silver nitrate. That is 6.7125 grams silver nitrate, silver chloride. We multiply this by the molar mass. So 1 mole of silver chloride per 143.32 grams of silver chloride. And then you multiply by the mole ratio, that is 2 moles silver nitrate is to 2 moles of silver chloride. And then we multiply by the molarity of silver nitrate, which is 0.0105. So 1 liter of silver nitrate per 0.105 mole silver nitrate. Okay, so grams AgCl here cancel out, and then moles AgCl, then moles AgNO3. Then we are left with liter silver nitrate. Alright, and this would give us a value that is equal to 0.446 liter of silver nitrate. So this is the volume of a 0.105 molar silver nitrate solution that would be required to react with magnesium chloride solution to produce this 8.95 grams of precipitate, which is 75% pure. Right, let's solve another problem. Right, in the given reaction, 63.2 grams of sulfur trioxide is produced using 40 grams of oxygen and 48 grams of sulfur. What is the percentage yield? So the given reaction should be sulfur plus oxygen. That would produce sulfur trioxide. Okay, this is right. So that is the given reaction. Okay, we calculate for the percent yield. Okay, we already given here the actual value, actual yield, which is 63.2 grams. So we need to solve for the theoretical yield of sulfur trioxide. So we start with 40 grams of oxygen. Then we multiply this by the molar mass of oxygen. And then the mole ratio. So 8 moles of SO3 is to 12 moles of oxygen. And then we multiply this by the molar mass of sulfur trioxide. Right, grams cancel out, number of moles. Then we're left with grams SO3, which is the expected value or the theoretical yield. So this gives us a value equivalent to 66.75 or 66.8. 8 grams of sulfur trioxide. Now we can calculate for the percent yield. This is just equal to 63.2 over 66.8 times 100%. And this is equivalent to 94.6%.